So let's have just a little fun, because what's life without a little fun? An ant. Okay, here's the truth table for the ant. So the yellow line shows me the current line. In other words, the ant starts off in the lost state, and see, none of his antennas are touching. So in fact, he has 0, 0. And so the yellow line will sort of tell me what the ant is thinking about in each step. Now that both antennae are on, it's going to rotate, whoops, it's going to rotate sorry. There he goes. Oh, now he's going to do that walking behavior. Here he's processing the corner. There he goes. Okay. This is actually a surprisingly sophisticated set of behaviors for what turns out to be a 4-state machine with 2 inputs and 3 outputs, right? I mean, this is, and in fact, a lot of the really, interesting behavior that you see in life, you sort of might speculate, could I build a finite state machine that implements that behavior? More on that thought in just a second. How do we initialize the state machine? How do we get the state how do we get the state machine hardware so that the encoding in the registers is in fact correspond to the initial state? Well, maybe I have to include some reset hardware. If my initial state has the encoding 0, often a convenient thing to do, maybe I'll include some reset hardware that forces that to 0. What happens if I don't use some of my state encodings? Well, we have to sort of defend against if we actually, cosmic rays hit and the state machine finds itself in an unused state encoding. We probably need to include some transitions that put it back into the world that we know. Okay, there's different ways. This is what's called a one-hot encoding, which involves, this is for the combination lock, where instead of having, encoding the state as an encoded binary number, we simply have one register for each possible state. That often makes the logic much simpler. Okay, this last bit about synchronizing input changes is something that we're going to deal with next time. But think about FSMs, okay? It turns out that there's a lot of behaviors in the world that are described by an FSM. It might be that if we dig down enough through all of our layers of particles and subatomic particles and sub-subatomic particles, maybe all of physics is really just a finite state machine with a couple of interesting transition rules. And here's the one I like to think about. Suppose you replace that read-only memory with a memory that can be modified, sort of to give your FSM learning behavior. And maybe that's all we've been all these millions of years, is an FSM with learning behavior. So a new philosophy of life.